if you're trying to complete the square, the big picture is to somehow take this and rewrite it so that you can factor it into two parentheses. That might look something like this. Okay, this is just an eyeball of the idea. This is not what this one's going to turn into, but you're trying to take this and write it so that when you factor it, it's the same thing times itself. We do that because then maybe you can take the square root of both sides to solve the answer. A square root and a squared sort of cancel each other out. So that's the goal, is to make it so you can factor into two parentheses so that you can say they're squared. So a good first step in factoring by grouping is to make A equal 1. Legal move in math is to take everything, divide it by some constant. Dividing everything by 2, that way my A in standard form can be a 1. So we got now x squared plus 1/2 x minus 3/2 equals 0, because 0 divided by 2 is 0. So first step is done. We got A equaling 1. Second step is to take this middle number, cut it in half, and then square the result. 1/2 divided by 2 is going to be 1/4. You can practice out that math because dividing means you would flip and multiply. 2 times 2 makes 4. So we took the middle number, we cut it in half, and now we're supposed to square that result. That's going to be 1/16. Okay, so the whole purpose of doing that was to let us be able to factor and make that perfect square happening, to factor into two equal pieces. I'm going to add a 1/16 to both sides. Got to keep it balanced, so if I'm going to add 1/16 to this side, I've got to add 1/16 to this side. And now, if you take this piece and factor it, you've got to find two numbers that multiply to be 1/16, but add it to be 1/2. Those numbers are 1/4 and 1/4. 1/4 times 1/4 makes 1/16. 1/4 plus 1/4 makes 2/4, which is 1/2. And look at that, they're the same parentheses. We got what we wanted. That's why we did the whole, that should be 1/2. That's why we did the whole thing where you cut B in half and then square it, because it makes you be able to factor perfectly. But we can't figure the minus 3/2 that was over here. It's supposed to be a 3. That looks ugly. And then there's all equal to 1/16. So before we take a square root, we got to set it equal to get the square root by itself. So we got to add that 3/2 to both sides. So you get x plus 1/4 squared equals 1/16 plus 3/2. That's the same thing as 24/16. So we got 25/16 on this right side. So this is the whole goal of factoring by grouping. Now we can take a square root to cancel out a squared. And you've got x plus 1/4 equals square root of 25 over square root of 16. Now I used my property of exponents there. If you're taking the square root of the whole thing, it's the same thing as the square root of the top divided by the square root of the bottom. But I'm also going to add something here, a plus or minus symbol. Because let's say the answer for x is going to be 5. If you plug in 5 in here, 5 and 1/4 squared is the same thing as negative 5 and 1/4 squared. When you're squaring a negative number, it's going to be turned positive. So every time you take a square root to cancel out a squared, you've got to add the plus or minus symbol. Think of two answers, positive or negative. So now we got that out of the way, let's keep going here. We can simplify the right side first before we get x by itself. That's square root of 25 over square root of 16, so that's the same thing as 5/4. So to finish getting x by itself, we solve twice. Once if it was the positive, the plus 5/4, and once if it was the negative 5/4. Okay, so to get this by itself, subtract 1/4 from both sides, and we're lucky here, we've already got common denominators. X equals 4/4, which is 1. Subtract 1/4 from both sides over here, and you get x equals negative 6/4, which is negative 3/2. Those are our two solutions. We solved by completing the square.